NASA officially denied that this recording ever existed. But in 2024, an audio engineer claimed he had recovered a corrupted file from an abandoned Mars archive. The first 11 minutes contained nothing but static. Then something began answering the wind. In November 2024, during a routine migration of archived mission data, a small team of contractors was assigned to transfer thousands of aging backup files from obsolete storage servers into NASA's modern archive system. Most of the files contained engineering telemetry, diagnostic logs, corrupted images, and incomplete communication packets that had accumulated over years of planetary exploration. The work was repetitive. Every damaged file was either restored, cataloged, or permanently discarded if recovery proved impossible. One backup package behaved differently. Its metadata was incomplete, but the timestamp was missing. The original mission identifier had been corrupted. The file extension suggested it contained raw audio, but no documentation explained why an audio recording existed in the first place. Mars rovers were never designed to capture long-form environmental recordings. Their microphones were activated only for short engineering tests or specific scientific objectives. This file lasted 23 minutes. No accompanying report referenced it, that no maintenance log mentioned it. No engineer had signed off on its existence. At first, nobody considered it unusual. Corrupted archives often produced meaningless files after years of storage degradation. The restoration software reconstructed the missing sectors automatically and generated a playable recording. The technician responsible for quality control expected to hear nothing more than compressed digital noise. Instead, the speakers filled with the unmistakable sound of Martian wind. It was quiet, dry dot constant. Exactly what every engineer expected from a microphone operating on the surface of Mars. The first several minutes appeared completely ordinary. Wind moved across the rover's chassis. Small vibrations traveled through its metal frame. Occasional electrical clicks came from onboard instruments switching between power states. Everything matched previous engineering recordings released during earlier Mars missions. The technician marked the restoration as successful and prepared to archive the file. Before closing the session, he listened through the remaining minutes simply to confirm that no additional corruption had survived the recovery process. That routine decision became the only reason the recording was never deleted. Around the 11-minute mark, a new sound appeared beneath the wind. It was so faint that it could easily be mistaken for background interference. The software did not classify it as corruption. It did not resemble electrical noise. It did not resemble radio interference. It repeated only once. The technician rewound the recording. The sound appeared again at exactly the same moment. He replayed the same section 6 more times. Every playback produced the identical result. Nothing in the waveform suggested random interference. Whatever had entered the recording was already present before the archive had ever been damaged. The file was removed from the deletion queue and forwarded for technical analysis. At that moment, nobody believed they had discovered anything extraordinary. They believed they had found an equipment anomaly. That assumption would survive less than 48 hours. The recovered recording was transferred to a small engineering review team responsible for validating damaged mission data before it entered the permanent archive. Their first task was simple: determine whether the newly discovered sound originated from the rover itself or from corruption introduced during the recovery process. The recording was imported into professional audio analysis software and compared with thousands of engineering recordings collected during previous Mars missions. The results immediately eliminated the most obvious explanation. The frequency of the sound did not match any onboard component. It was not produced by the rover's wheels. It did not match the electric motors controlling the robotic arm. It was not generated by the cooling system, the onboard computer, or the power distribution hardware. Every mechanical component produced a unique acoustic signature during operation. This sound matched none of them. The engineers then considered atmospheric interference. Dust particles driven by powerful Martian winds can create low-frequency vibrations when they strike exposed metal surfaces. Similar effects had already been documented during several missions. To test that possibility, the recording was compared with hundreds of hours of environmental audio collected under different weather conditions. The comparison produced another unexpected result. The wind behaved exactly as expected. The unidentified sound did not. Its frequency remained perfectly stable while the surrounding environment constantly changed. Wind speed increased. Temperature dropped. Instrument noise fluctuated. The unidentified signal remained identical. The engineering team requested a spectral decomposition of the recording. Instead of listening to the sound, they examined its frequency distribution. Natural environmental noise produces irregular patterns. Mechanical systems generate harmonic structures that engineers can identify within seconds. The recovered signal belonged to neither category. It occupied an extremely narrow frequency band and maintained the same energy level throughout every occurrence. One engineer suggested that another transmission might have accidentally merged with the archive during years of repeated data migration. The hypothesis seemed reasonable. The archive was searched for every recording sharing the same spectral fingerprint. Nothing was found. The signal existed only once. The discovery changed the nature of the investigation. The objective was no longer to repair a damaged recording. The objective became identifying a sound that should not have been present in the first place. During the final review, one of the engineers noticed a detail that everyone else had overlooked. The signal never appeared while the rover was moving. It only occurred after the vehicle had been completely stationary for several minutes. Every appearance followed the same sequence. The rover stopped. The surrounding wind slowly weakened. Several seconds later, the unidentified sound emerged beneath the background noise. The pattern repeated every single time. That observation raised a new question. If the signal was not produced by the rover, why did it always begin only after the rover became completely still? Nobody in the laboratory had an answer. The investigation was expected to end within a week. The engineering team had documented the unidentified signal, archived the analysis, and prepared a report describing it as an unresolved acoustic anomaly. That report was never submitted. Before the documentation could be finalized, one of the engineers decided to perform a simple verification. If the sound had originated from the rover itself, it should have appeared in other recordings captured during the same mission. He requested access to every surviving audio archive associated with the vehicle. The search returned only 4 recordings. 3 had already been examined years earlier and contained nothing unusual. The 4th recording had never been restored. It was heavily damaged and had been marked as unrecoverable shortly after the mission ended. The engineering team decided to process it anyway. Recovery took almost 14 hours. Nearly 60% of the original data had been lost. Large portions of the recording were permanently unreadable. Even after reconstruction, the file contained long sections of digital silence where information could never be recovered. Nobody expected it to reveal anything useful. The first 10 minutes confirmed that assumption, not only wind, static, occasional vibrations from the rover's chassis. Then the analysts reached the section that had survived the corruption. The same sound appeared again, not similar, the same. The waveform matched the first recording with remarkable precision. Its dominant frequency differed by less than 1%. Its duration remained identical. Even the interval between the pulses was unchanged. The probability of 2 independent mechanical failures producing an identical acoustic signature under completely different environmental conditions was considered extremely small. The comparison software highlighted another detail. The second recording had been created 34 Martian days after the first one. Despite the time difference, the unidentified signal had not changed. Whatever produced it had remained active for more than a month. The laboratory requested every remaining engineering backup associated with the mission. Only 1 additional recording was recovered. It had been captured near the end of the rover's operational life. The engineers expected another perfect match. Instead, they discovered something that immediately halted the review. The signal was no longer identical. Its frequency had shifted slightly. Not enough for a human listener to notice. Enough for analytical software to measure with complete confidence. The pattern had evolved. For the first time, the team stopped referring to it as an acoustic anomaly. They began calling it a repeating source. One engineer summarized the discovery during an internal meeting. If this is environmental noise, it should be random. If it is mechanical, it should degrade over time. This recording does neither. No one challenged the statement. The room remained silent. A decision was made to compare the recordings against orbital maps captured during the same period. The goal was simple. Determine whether every recording had been captured in the same location. The answer would change the direction of the investigation forever. The orbital data arrived the following morning. Every recording was placed on a topographic map of the rover's route and compared with its exact coordinates at the moment each audio file had been captured. The first recording came from Sol 417. The second was recorded 34 Martian days later. The third was captured near the end of the mission, almost 6 months after the first. By every reasonable expectation, the rover should have been in completely different locations. It wasn't. The recordings had all been captured within a radius of less than 30 meters. The engineering team checked the navigation logs twice, then a third time. There was no mistake. The rover had returned to the same location on 3 separate occasions during different phases of the mission. At first, nobody considered that unusual. Mars rovers frequently revisit areas that offer scientific value. Rock formations, sediment layers, and unusual mineral deposits are often examined more than once. The mission planners retrieved the original route documentation to determine why this location had received so much attention. The answer created another problem. According to the official mission timeline, the rover had never been scheduled to stop there. The waypoint did not appear on any published navigation plan. No scientific experiment had been assigned to that position. No drilling operation had taken place. No soil samples had been collected. From the mission's perspective, the location had no importance. Yet the rover visited 3 separate times. The navigation software showed something even stranger. Each visit lasted significantly longer than planned. During the first stop, the rover remained stationary for 18 minutes. During the second, it remained there for 26 minutes. During the final visit, it stayed in exactly the same position for more than 40 minutes before continuing its route. The engineering logs reported no hardware failure. Battery levels remained normal. Motor temperatures were within operational limits. Communication with Earth never dropped. Nothing explained why the vehicle had stopped. One member of the navigation team suggested a software malfunction. Perhaps the autonomous navigation system had temporarily paused while processing terrain data. The software logs rejected that explanation. Every autonomous decision made by the rover was recorded. No pause command existed. No obstacle avoidance routine had been triggered. No emergency procedure had interrupted the mission. The rover had simply stopped. It waited. Then it continued as if nothing had happened. Attention shifted from the audio recording to the terrain itself. High-resolution orbital imagery was requested from multiple observation passes over the same coordinates. The photographs showed an ordinary section of Martian landscape. Dust. Rock. A shallow depression measuring roughly 40 meters across. Nothing that justified repeated visits. Then one imaging specialist compared photographs taken several months apart. He wasn't looking at the surface. He was measuring the shadows. One shadow changed between passes. Not because the sun had moved. Not because the camera angle was different. The object casting the shadow had changed position. There was no record of any structure in that location. No boulder large enough to produce the measurement. Nothing visible on the ground that could explain the difference. The change was small, less than a meter, but it was real. The specialist repeated the calculations using independent software. The result remained exactly the same. Something at those coordinates had moved. Not quickly, not dramatically, just enough to be measured from orbit. At that moment, the investigation stopped being an audio analysis. It became an investigation into a location on Mars that official mission records could no longer explain. The final stage of the investigation focused on the rover itself. If the location offered no explanation, perhaps the vehicle had recorded something its operators never noticed. Every engineering log from the 3 visits was reviewed line by line. Power consumption, temperature, navigation, communication. Wheel traction, battery health. Nothing appeared out of the ordinary. Then one systems engineer opened a diagnostic log that had never been included in the public mission archive. Unlike the engineering reports, this file had not been written by a human operator. It had been generated automatically by the rover's onboard software. Most of the entries were routine. Camera initialized. Navigation updated. Environmental sensors active. Battery operating within normal parameters. Halfway through the log, one entry interrupted the sequence. Audio acquisition initiated. The engineer stopped reading. Mars rovers could activate their microphones automatically, but only under specific conditions defined before launch. Dust events. Mechanical diagnostics. Scientific experiments requested by mission control. He searched the following lines for the command that should have triggered the recording. There wasn't one. No instruction had been transmitted from Earth. No onboard routine had requested an audio capture. According to the diagnostic log, the microphone had activated itself. The software immediately flagged the event as an anomaly. 4 seconds later, another entry appeared. Signal source, unknown. The engineering database contained hundreds of predefined categories for sensor activity. Mechanical vibration, wind interaction, electrical interference. Surface impact, none of them had been selected. The software had generated a category that should not have existed. Unknown. The team assumed the log had been corrupted. To verify the result, they restored the original diagnostic package from the backup archive. The restored version contained the same entry. Every checksum matched. The file had never been modified. Attention returned to the recording. The engineers synchronized the diagnostic log with the recovered audio. The exact moment the microphone activated matched the beginning of the unidentified signal. Not 1 second earlier, not 1 second later. The rover had started recording only after detecting something its own software could not classify. No explanation inside the engineering documentation accounted for that behavior. The investigation continued for another 3 months. No additional recordings were found. No matching signals were discovered in any other mission archive. The final report was completed, but never assigned a conclusion. Under the section labeled Source, a single sentence remained. The origin of the recorded signal could not be determined using available engineering data. The archive was closed. The recording remained stored with thousands of unrelated mission files. Years later, during another migration of aging servers, the backup package was scheduled for deletion. Most of it disappeared permanently. One recovered copy survived. It contained only the audio. No report. No explanation. No conclusion. Only 23 minutes of Martian wind, and a sound that no one could identify. If the engineers were correct, the recording captured nothing more than an unexplained acoustic anomaly. If they were wrong, then somewhere beneath the surface of Mars, something produced a signal that was detected on 3 separate occasions over 6 months, yet never appeared in a single official mission report. The recording ends without an answer. Perhaps that is why it has never been forgotten. Before this archive was permanently deleted, one engineer added a final note to the investigation. It contained only one sentence. If anyone ever identifies the source of this signal, they should compare it with future Mars missions. More than 20 years have passed. No official explanation has ever been published, Dot. So now I have one question for you. What do you think the rover actually recorded?